Hi all. In this video, we'll talk about priority queue. We will see what a priority queue is and then we'll go to the implementations of priority queue. There are different data structures that can be used to implement a priority queue. We'll see the pros and cons of each approach. And based on our use case, we can choose any of those. Yeah, coming to the working of the priority queue, I'll explain this with an example. Okay. First, let us consider we are taking a class, and in a class we'll have students, right? So each student has roll number assigned, and let's say we have conducted an exam, and we assigned marks to the student. Based on the marks, there is a rank for him. Now I want to give some awards to the students based on their ranks, and I want to give punishment also based on the lowest ranks and awards based on the highest ranks. Let's say I want to select first highest student based on the rank, and the second person who got second rank student, and the third rank student. And likewise I want to fetch the lowest rank students as well. So if I use array, now here my priority is a student has different characteristics. He has name, roll number, rank, everything. But my priority here is rank. I'm not concerned about when he joined or not. I'm concerned about rank here. So my priority here is rank. Now I'll insert the students to a list. Okay. First student 1, student 2, student 3, student 4. But when I'm fetching, like when I say I want first rank student, I should get the first rank student immediately. When I dequeued, I have assigned students to a list, and when I remove a student from the list, what I want is I want the highest rank student. Now for the first time I have fetched highest rank student. S4, letter S4 is the person who got the first rank. So when I removed element from this list, I should get S4 first. And after that, when I removed element for the second time, I should get S2, who is the second rank student. And when I removed third time, when I removed element from the list for third time, I should get S1. S1 is a third rank student. So I should have a data structure which does this. Basically, whenever I insert elements to a list based on a priority, I'll tell them while inserting to a list, I'll tell to the data structure that rank is the priority. I'm inserting so and so element, and element has multiple characteristics, but out of these characteristics, this is the element I'm considering as a priority. So it's your wish. Like you tell to the list that it's your wish how you store the data. But whenever I ask, I should get the highest priority element first. When I remove the first highest priority element, I should get the second highest priority element second. So that is what a priority queue is. So each item in a priority queue has a priority associated with it. So when I'm storing list of students, priority assigned here is rank. Now other person, they might want to fetch students based on the roll number as well. So in that case the priority changes. It becomes roll number becomes the priority, and when I fetch a student, I should get the highest roll number student first. And when I removed when I asked for the second time, second highest roll number student should come first. Okay, that and coming to the second point, when your DQ is operation is performed, basically DQ is nothing but removal. Whenever you remove an element from that list, item with highest priority is DQ'd. Okay, so this is the example, because there are so many use cases where you want to fetch only the first like topmost students or topmost or least students. The topmost students criteria varies, so in those applications we'll use the priority queue. And coming to the implementation of priority queue, there are three data structures that can be used to implement a priority queue. One is array, and second one is linked list, and the third one is the heap. Okay, so for the array, let us what we'll do is whenever I get an element, I keep adding here. So here I'm considering list of integers as my elements, and the priority here is I consider the element value itself as my priority. I'm inserting 2. So while inserting itself, I should tell the priority, right? My priority is the value itself. Element value itself is my priority. There can be cases where I'm inserting integers. There can be cases where I insert students. So while inserting the student, I tell them the roll number or rank is the priority. But here, since I'm inserting the list of integers, number itself is a priority. So I insert 2 because I get 2 first, and then I inserted 4, I inserted 10, 5, 15, so on. I prepare a linked list also. Here linked list is 1, 2, 3, 4, 5. These are addresses. We discussed about linked list, right? Linked list store the address of the next element. Here 30 is the address, it stores it. Okay. And for the max heap, what we do is whenever we inserted the element 10, 9, 7, this is how you store it in the heap. And we know how a heap works, right? So for the max heap, the root element has the highest value. Okay. Now we'll consider the operation. So first operation is insertion and the second one is the dequeue operation, right? So in an array, what I'll do is I'll insert at the end of the list, at the end of the array. So insertion operation to an array takes order of 1 time, because just you have a vacant space here and you are just inserting the element. So order of 1. While deleting, and if you remember the functionality of priority queue, while deletion you should get the highest priority element first. So now I'm deleting it. So while deleting it, the highest value, highest number should be given to me. So to fetch the highest number, what I should do, I should traverse element one by one, because this is not in sorted order, right? This is in zigzag fashion. So to fetch the highest element, first I'll go here 2. Then first I'll go to 2, right? First I'll search here 2. And then I'll go to 4. Now my highest element is 4. When I went to 10, my highest element till now is 10. So when I went to 5, my highest element till now is still 10. Okay. Now later on, when I went to 15, my highest element is 15. When I went to 3, my highest element is still 15. When I went to 20, my highest element is 20. When I went to 1, my highest element is still 20. So you have to traverse each and every element and then finally find which is the highest element, because my priority here is the value itself. So I found out that 20 is the element that has the highest priority. Now what should I do? I should delete it. So finding the highest element takes order of n time, because the highest element can lie at the end of array as well. So you have to traverse the whole array to find out the highest element. So deletion, first finding out takes order of n, and deletion time complexity is as order of n as well, because let us suppose first element it's the highest element. Now when I remove this, when I remove from the array, I have to shift all elements to the left, right? So shifting takes order of n. So searching for the highest element takes order of n, and shifting element takes order of n. So total order of 2n. Order of 2n is nothing but order of n, right? So that's why deletion here is order of n. Now peek is nothing but finding. So insertion is you insert an element, deletion is you find out and then you delete element. Peek is nothing but find out. So here, as we discussed just now, finding out also takes order of n, because you have to traverse the whole array to find out the largest element. That's why peek time complexity is order of n. Now let's come to a linked list. So if you think about linked list functionality is slightly different from array, right? Because for array, since it is a contiguous data structure, you just go to the last and then you create some vacant space and then add an element. But for linked list, since it's not contiguous, let's say I have to insert one more element here. What I have to do? First I have to go here and then fetch the second address 30, and then go to 40, and then go to 50. Likewise, I should go to 60. Then here I'll add one more element. Let's say this memory location is 70. So I have to add here 70. So here insertion takes order of n. Now, anyway, we are inserting the element, right? While inserting itself, let's arrange it in a sorted way, because now initially I arranged it one. Initially, let's suppose this is the element I have inserted first to in an linked list. Now, next I got one. So what I'll do is I'll compare 1 with 2. Okay, now I'll compare 1 with 2. And since 1 is smaller than 2, what I'll do is instead of putting this element next, I'll put it to the previous. I'll just change the memory address of this. That can be possible, right? So in a linked list, while inserting itself, we make sure this is in a sorted way. This is one way. I'll arrange this in like in a sorted way. So insertion takes order of n, because since we are making it in a sorted way, let's suppose I have to insert 70 element now. Yeah, so here 5 is there, right? Now I have to insert an element with 10 value. So what I have to do, I come here, compare 10 with 1, and then since it is larger, go to the next element. 10 is still larger than 2. So likewise, I'll traverse till the end of the list, and then I'll insert the element. So insertion takes order of n. Now deletion. Coming to the deletion, since priority queue, what we'll do is we'll fetch the topmost element, like topmost element, right? So what you can do, either it based on the priority we are fetching. So what you can do is, since you have the tail node, we can just come here and make this address point into null. Now let's say I want to this is the element with 10, right? Now you in a linked list, you store the head node as the head node and the tail node, right? I have a tail node anyway. So what I'll do is tail node dot previous, tail node dot previous, I'll fetch this element, and this element currently is pointing to 10. So I will delete this element. Deleting is nothing but removing the link. Removing the link is nothing but updating the address here, right? So what I'll do is I'll update the address to null, and anyway I have the tail node value. Tail node is the one with the largest one. So deletion will not take much time, because you're just removing the link. You're not shifting elements. In the array, if you remove an element, you have to shift it completely. But in the linked list, you need not do that. So that's why deletion takes order of n. And peak element, fetching the largest elements also is order of 1, because now I arranged the elements in ascending order. Now I can do the same in descending order as well. So if I do it in ascending order, I can use the tail node value as my largest element. If I do it in the descending order, I can use the head node value as my largest element. So to understand more about the linked list, you can watch my initial video about the data structure, where you'll get a little idea about that. So order of 1 is the time complexity of the peak. So we discussed about these two. Now let's talk about maximum heap. So like in the previous videos, we understood, right, the maximum heap insertion. So in a heap insertion, order of log n is the time complexity, because you insert an element here at the end, and then what you do is you keep pushing it like this. You keep pushing the item to the top till it reaches top. So maximum time complexity is the height of the tree, and height of a binary tree is order of log n. And deletion, whenever you delete element, deletion is nothing but removing the peak element, right? Removing the element that has the highest priority. Anyway, topmost element is the highest element. When I remove this, what we'll do? We will shift this 2 here, and then to make heap working, like to when I swap this 2 with 10, what I'll do, heap should follow the complete binary property and as well as the maximum node property, because root node should be greater than all of its tail nodes, right? Then what you'll do, you keep pushing the element to the bottom. So here also my time complexity would be order of log n, because maximum time that takes for the deletion operation is order of log n, because it's a height of the tree. Now peak element is nothing but you just fetch you get the value, you just get the largest value, you need not delete it. So getting the largest value is nothing but you fetch the root node, so order of 1. So if you consider the time complexities among array, linked list and the heap, So in array, one operation is order of 1 and the remaining operations are order of n. Okay. And in the linked list, one operation is order of n and the remaining operations are order of 1. But in heap, if you see, order of log n, so it's not completely order of n. Okay. So if you are not concerned about, if you are not like if your use case has more insertions and more deletions, then we can use heap. It depends on our use case. In few cases you may not have much insertions, only a few insertions, then you can use linked list. But here, for if you use a heap, you will, for in terms of time complexity, it would be much better using a heap. But we can implement it using array and linked list as well. Yeah, thank you. In the coming videos, what we do is we'll solve problems related to heap, right? So in most of the problems, you see me using the priority queue. That's why I explained about priority queue, because priority queues are implemented using heap. That is why we spoke about priority queues here. Yeah, thank you. We'll solve more problems.